So our topic for today is all about solving quadratic equations by completing the square. Okay, ax squared plus bx plus c is equal to 0. It can be into form of the quantity of x minus h to the power of 2 is equal to k, where k is the constant and k should be greater than or equal to 0. In solving quadratic equation by completing the square, we need to follow steps. Okay. Solving quadratic equation by completing the square. First, we need to divide both sides of the equation by a, then simplify. After dividing both sides, next we will write the equation into the standard form, or into x squared plus bx is equal to c. Next, add the square of 1/2 of the coefficient of the x on the both sides to become perfect square trinomial. So our target for this is to have perfect square trinomial. Okay? Next, express perfect square trinomial on the left side of the equation as a square of binomial. So when we get perfect square trinomial, we can have binomial, or we can also have perfect binomial. Okay? Solve the resulting quadratic equation by extracting the root. Then after we have by two terms, or the binomial term of the trinomial equation we need to apply the extracting the root. Okay? We also have tutorial about solving quadratic equation by extracting the root. So you can also watch our video to understand this. Okay? Then solve the resulting linear equation, then do the checking to example. But first, okay, we'll use this one. So it states here that divide both sides of the equation by a, then simplify. So in our equation, where is the a in a quadratic equation? So the a in this equation is this 2. Okay? 2x squared plus 8x minus 10 is equal to 0 divided by 2. Okay, we need to divide everything into 2. Okay, 2x squared divide 2 is x squared, 8 divide 2 is 4, and negative 10 divide 2 is negative 5 is equal to 0. Then we need to write it in the equation that the c will be on the other side. Okay, we will use additive inverse to this. So it will be 2x ax squared plus 4x is equal to positive 5. So next, add the square of 1/2 of the coefficient of x on the both sides, to this side and to this side, to become a perfect square trinomial. So add the square of 1/2 of the coefficient of x. So 1/2 add to 4, it will be 2. So the 1/2 of 4 is 2. And it states here that we need to square this up. Okay, the square root of 2 is 4. So in short, we need to add 4 to both sides of our equation. Okay, it will be x squared plus 4x plus 4, as we added 4, is equal to 5 plus 4 is, okay, 5 plus 4 is 9. So now, in this area, we already have perfect square trinomial. So since we have perfect square trinomial, we can make a binomial to this. So what are the two numbers that when you multiply, it will equal to 4, and when you add, it will equate to 4 also? So the two numbers are 2. So it will be x plus 2 squared, or x plus 2, quantity of x plus 2 is equal to 9. Since these two terms are the same, we only have to use one. Okay? X plus 2 is equal to 9. So it states here that solve the resulting quadratic equation by extracting the square roots. So we need to extract square root. Okay? So let's square the 9 first. So positive negative square root of 9 is 3. So x plus 2 is equal to positive negative 3. Since our 9 here is a perfect square, we need to solve for two value of our x. So let's do it. 2, we'll use negative 3 here, and over here we'll use positive 3, equal to 3. Okay? With an additive inverse, it will be x plus 2 minus 2 is equal to negative 3 minus 2, cancelled out. So x is equal to negative 3 minus 2 is negative 5. So the first value of our x is negative 5. Then x plus 2 minus 2 is equal to 3 minus 2. So cancelled out. X is equal to positive 3 minus 2 is positive 1. So now we already have the two value of our x, which is negative 5 and positive 1. In checking, we'll use this equation, our given equation. Okay. Since we get the negative 5 first, so we'll use this. So 2 to the quantity of negative 5 squared plus 8 quantity of negative 5 minus 10 is equal to 0. So you already what you were going to do is to replace all the variables to its value. Since we used the negative 5 first, so all the x variable will replace with negative 5. So by the rule, we need to solve for every number that's inside the quantity sign. So negative 5 squared is 25 times 2. 25 times 2 is 50. 8 times negative 5 is 40. So negative times positive, so negative 40, and minus 10 is equal to 0. So combining like terms, 50 minus 40 is 10, minus 10, so 0. So our x is equal to 5, x is equal to negative 5 here is correct. So next, we'll use this one. So here, we'll use 2 to the quantity of 1 squared plus 8 times 1 minus 10 is equal to 0. So 1 squared is 1 times 2 is 2 plus 8 times 1 is 8 minus 10 is equal to 0. So 2 plus 8 is 10 minus 10, 0. So 0 is equal to 0. So therefore, it is true that x is equal to negative 5 and x is equal to 1 in using quadratic equation by completing the square. Our second example is x squared plus 3x minus 18 is equal to 0. Okay? Okay. As you observe, the value of our a here is already 1. So, we don't need to divide both sides into a. X squared plus 3x is equal to positive 18. Okay, same as what we did earlier. We need to add the square of 1/2 of the coefficient of x on the both sides to become perfect square trinomial. The 1/2 of 3 is 3/2, of course, 3/2. So we need to square this. 3/2 squared is 3/2 squared. 9 times 9, 3 times 3, 9, 2 times 2, 4. So we have 4 over 9. Add both sides with 9 over 4. 9 over 4. X squared plus 3x plus 9 over 4 is equal to 18 plus 9 over 4. Since our constant here is 18 plus 9 over 4, as you can see, 18 is a whole number, while 9 over 4 is a fraction. So, are we able to add them both? Okay. We have to do things for them to be able to combine or to be added. Okay. What are we going to do? Okay. On this side, we need to have a denominator of 4. So we can add 9 over 4 to the given constant. Okay. But how we do it? Okay. First, let's copy 9 over 4 plus 4. So, in adding fraction, we need to have same denominator. So, since we put 4 as a denominator of 18, so we need to times or multiply 18 into 4. So, 18 times 4 is 72. So, now, they already have same denominator, so we are able to add them. So, it will be x squared plus 3x plus 9 over 4 is equal to 81 over 4. Since it is already perfect square trinomial, we can now have the binomial. So, x squared plus 3x plus 9 over 4 is equal to x plus 3 over 2 or 3/2 squared. So, the binomial of the perfect square trinomial x squared plus 3x plus 9 over 4 is x plus 3/2. So, equate it into 81 over 4. So, earlier, I did not clearly told how to get the square root of it. So, x plus 3 over 2 squared is equal to 81 over 4. So, we need to subtract their square root. So, squared here and squared of here. Cancel. So, earlier, we just used the easiest way. So, it will be x plus 3 over 2. So, what is the square root of 81 over 4? So, 81, the square root of 81 is 9. And the square root of 4 is 2. Now, to get the value of x, we use additive inverse. So, x is equal to 9 over 2 minus 3 over 2. Since they have the same denominator, we can easily subtract. Okay, x will be equal to, copy the denominator since they have the same, and 9 minus 3 is 6. So we can still have a fixed value of x here. So 6 over 2. 6 divided 2 is 3. So x is equal to 3. X is equal to 3. So we already have the first value of x. Next, we'll use x plus 3 over 2 is equal to negative 9 over 2. Okay? With the additive inverse. Equal to negative 9 over 2 plus minus negative 3 over 2. Okay? X will be equal to, copy the denominator because they are the same. Negative 9 minus 3 is negative 12. So negative 12 divide 2 is equal to negative 6. So the value of our x here is positive 3 and negative 6. So x squared plus 3x minus 18 is equal to 0. We'll use positive 3 first. So 3 squared plus 3 times 3 minus 18 is equal to 0. So 3 squared is 9 plus 9 minus 18 is equal to 0. 18 minus 18, 0 is equal to 0. So this is correct. The other one, negative 6 squared plus 3 power of 6 minus 18 is equal to 0. So 6 squared is 36, positive 36, plus negative 18. My negative 18 is equal to 0. So 0 is equal to 0. So the value for x is 3 and negative 6. Okay, that's all. I hope you learn something about this.